Hello everyone, this is Reza. Welcome to another video of Nuke for Beginners series. In this video, we are going to talk about the footage, bit depth, and a linear light space and how to output our footage. So I have different images here in my scene. Let's explore them one by one. Now, the most common one is a low dynamic image, such as JPEG. Now, usually any 8-bit JPEG extension comes with standard red, green, blue sRGB as the native color space. Now, sRGB color space is composed of a limited amount of color information that it used to optimize and streamline the colors. Now, while it's quite helpful because it's optimized, it's fast, it's quick, it's straightforward, it may create some confusion for Nuke, since Nuke uses a different color space as default color space, and that color space is called linear color space. So in order to read that, Nuke needs to convert everything to linear. But to do that, it needs to identify the color space of that image to begin with. Now, if you have a high dynamic range image, such as this one, then Nuke has no problem identifying the actual color space for that image. But if it's low dynamic, Nuke needs to adjust the gamma correct the image so what you see is accurate. If I go over here, there's a very useful piece of document written by Steve Wright about how color management works within Nuke and how conversion happens and how Nuke actually converts all images into linear light space, which I highly encourage you to read. I put a link in the description below so you guys get to read the whole thing thoroughly. But basically that is the intention. That's what you get. That's the gamma curve that you get with CRT monitors. And if it wasn't for Nuke to correct this coloration, then you would have seen this, a tad darker image. Now, after gamma correction, you can see Nuke automatically correct the gamma, so the monitor can show the gamma curve as it's intended to begin with. So it's just a process that Nuke does behind the scene. So every time you input an image, Maya goes through that linear light space, fix the gamma if need be, and then write it with the new gamma so you see the image with the right the colors. So the color management inside Nuke is something that you need to be mindful of. If I get rid of the property bins and press S to bring the project settings, apart from the path to the directory and the frame range and the frame per second and the format and file size, we have a separate tab just for color management. Now you can see linear is where it's intended. That's the ideal scenario. If you have an input and that input is linear workspace, that's what you get. But if it's JPEG or low dynamic image or video, this would be what you're getting. Even with some broadcast devices like Rec 709, you still have that gamma problem when you view your image through CRT monitors. With Cineon, which introduced by Kodak, and it's almost an obsolete, unfortunately obsolete extension these days. Back in 90s it was quite popular. You can see the gamma curve is even stronger and sharper. So if I were to actually see this image if I double click on it and see the raw data, you can see that that's what you're getting without the color management side of things. So Nuke is actually quite smart in these scenarios. It identifies the lookup table and converts this with the proper color management. It handles the scenario where we see the right coloration as opposed to a washed out look or darker look. So it is quite important to be aware of the color spacing, how it works, the variety, and how gamma has an impact on the end result, and how Nuke handles or manages the scenario. Now, once we understand that, you can see we can import a variety of lookup tables or color spaces. So this is a low dynamic sRGB, and this is high dynamic linear, which I rendered out of Maya. It's an EXR file, and EXR files are more than capable to store more information. A typical Cineon file, a test render that I did in Houdini, and it's an MPEG-4, so you can actually bring videos in using the letter R on your keyboard or through this menu here. You can actually bring a frame that is part of a sequence. So you can see that's just a frame, a single frame. Or you can actually bring the whole sequence. If I press R, you can see that if I were to bring this cloud, you can enable that sequence button and bring the entire sequence. You can split that sequence as well, but I tend to bring the sequence here and edit it here. But once you bring it, although it brings it as a single read node, you can actually play, get the buffer done, and then see it in almost real time. You can change the frame per second, and you can actually set your playlist to see or look into the input node and see it that way. So it is actually quite useful that we have this as an automated process in Nuke, and we don't need to worry about it. We do need to be aware of it when we import any extensions into the software. Now, another thing I need to talk about is the color value. So if I bring my read viewer node in here, connect it to my low dynamic range image, you can see if I hover my mouse, you see the color chip here appearing that says there is no value over 1. I can just target the brightest area and get 1, but there is no value over 1. It means that there is limitation within each pixel in terms of color values. You cannot go over 1. And if I were to add any type of color correcting modifiers, such as grade or color correct, you can actually go minus and introduce artifacts in your scene. So I'm just going to type grade to bring a color grade node, bring it in, plug it in, and I'm going to disable black clamp and white clamp and just bring down the lift a little bit, and now do the same thing, hovering my mouse and look at the values in the color chips. I've introduced minus, which is actually quite problematic. So Nuke knows that sometimes we use grade, and this is absolutely necessary to switch everything not to minus but to 0. If we go below 0, if these values go below 0, so it actually clamps the black points and white points if need be. So it can be the other way around, where we get to the information that we actually get no information at all. Having that control over a low dynamic range image is actually quite useful. We are not going to run into this problem that much in a high dynamic range image. So if I select the high dynamic range image, I'm going to reset everything. And the way that you reset a knob, if I were to, for example, change this like that, you either right click and go revert the knob, or you just control middle mouse to reset that knob. Now, I can actually hover my mouse and you can see, yes, we get probably the same read 0 to 1, but we go over 1 in some areas. Look at that bright area. The color chip actually reads 1.02 for red, 1.04 for green, and 1.2 for blue channel. Now that's extra level of information we have access to help us with color management, which is good. So unlike low dynamic range, high dynamic range offers us more values within each pixel, so we have a little bit of room to wiggle. That's fantastic. Now back to this low dynamic range. If I were to sample a color, you know, for example, I have this color here, I would like to sample a color. There is a node called constant, which I created already, but you can actually just type in constant and you get it. That constant is just like a flat matte color that you introduce in Photoshop. And you can actually sample a color like that. So if I bring this here, you can actually select that and sample a color. You can actually select this color chip, drag and drop it into your constant and sample a color from your image. And it doesn't matter if it's high dynamic or low dynamic. And that's a really nice way of picking the color in case if you would like to composite that into the background, or you're putting together a collage for scene extension and you would like to use the same value. That's a really nice shortcut to do that. You can also sample colors by holding down Control and click, and you can see I just sampled a color value per pixel. Now if I hover my mouse, the value won't change because it's just fixated on this sample color that I picked. I can just Control and click to sample another area or another region, and you can see the color chip constantly updates itself because I created a link. Now if you want to sample a region and not just a pixel, you can just hold down Control Shift and drag, and that gives you an average value of the selected region. If you want to get rid of it, you can always zoom back and Control click and it goes away. Control click on the outside. So having that color selection and color picker using Control and click can be quite helpful for you to sample the color value and use it in other areas if you want to. Now that's done, let's go and talk about bit depth. I'm just going to plug the viewer to the first image. So what I have here, I have a low dynamic and high dynamic image. And the first glance may be quite misleading. So what do I mean by that? If I press 1 and then 2 to connect the two and then toggle between 1 and 2 using my keyboard numerical pads, you can see there is absolutely no change in the look of these images. I can toggle between 1 and 2, but again what I see is identical. Now first things first, I'm just going to basically have a look at the color values, and then you can very soon realize that there is actually a big difference between the two. I'm going to hold down Control Shift X and let's bring the grade node to this guy. I'm going to detach. Now if I bring the grade node, you can see that I'm going to just you can see that if I click and sample colors, I'm still getting everything under 1 or 1. With the high dynamic, I get over the value of 1 really quick. And again, I'm using Control and click to sample, and you can see that color picker is enabled now. You can even select the region, Control Shift, but again, the value is almost 2. In green channel is actually above 2, almost 3. So it means that it's holding quite a lot of information. But the question is, how can we use that amount of information? You use this information when you use a node like color grade. Now it allows you to change the coloration of your image during color correction phase without destroying the information. Now if I bring this to 1 and I start changing some of these values within this grade node. For example, I'm just going to bring the, let's say bring the multiply down. Now as soon as I bring the multiply down, you can see that we are actually losing information here. It becomes even clearer if I use the viewers knob here. I've got 1 for gain and 1 for gamma. So if I bring the gain down like so, you can see that we're clearly losing information. So that highlight, this area, is no longer white. If I using my old trick, using Control click, it still says 1, but I'm not getting that white highlight anymore. So that can be a problem. If I use the same trick, and I'm going to click on this value to toggle or to reset this knob, this time let's go and use the high dynamic, and I'm going to do the same thing, lowering the gain, but you can see that the color, the highlight, actually preserves itself. So yes, we have a darker area overall, but the highlights will stay put, whereas in low dynamic that was not the case. I'm just going to press 2 to have low and high, so I can have back and forth, or even better, with those two selected, I'm going to hover my mouse over the viewer and press W to enable the wipe. Now the wipe is really good for before and after cases. So you can see now I have my wipe enabled. Read 5 and read 6 are plugged to these two. And then you can see a transition that is happening. So if I zoom in, you can clearly see using the wipe as a helper. You can see low, high, low, high. So low dynamic range, high dynamic range, you can see how different the bit depth is and how much you can preserve in a high dynamic range image, an EXR image, as opposed to a low dynamic range or JPEG image. The reason that I'm setting the time aside to explain this, because that many students do ask me that what's the difference between the two, because first glance they look identical, even the quality is not that different, but when you start tweaking the image using some of the nodes, that's where the problem comes from. In low dynamic images, they cave in, they collapse, they lose information really quickly, whereas the high dynamic ones tend to preserve the information better because they've got more values. They've got higher values stored in each pixel. The next chapter talks about color grading. Now, I'm not going to talk about color grading in depth just yet, but how to color grade an image when you have transparency, because there are some tricks in there. Now, we already know about transform. We already know about reformat. So we know that if I plug this transform node here, and if I were to grade this, I'm getting an optimal result, right? This is something that we discussed in the previous video. Now, one thing you need to be mindful of is every time you bring an sRGB image, You can double click on it to confirm or verify. And you would like to add color grade. You need to pre-mult it. You need to pre-multiply this, and it helps you with the edges of your image. Now, if I were to use the color grade to grade this node, you can see if I go to something like lift and start lifting the image, the problem is now I'm lifting the foreground and the background. That can be quite confusing because your grade node is sitting on the foreground only, has nothing to do with the background. And we did talk about this in the previous video where we said you put A over B, B should not be affected. But in this case it is, because there is no multiplication. So we have two nodes, unpremultiplied and premultiplied, and we need to use them every time we run into these type of scenarios. So if I bring this here, I'm going to select these guys, move them to the side. You first need to unpremultiply it, unpremultiply your foreground, and then premultiply your foreground right after you apply grade. Now, if I put this in a more visual way, this must be the bracket that you always follow when you try to color correct a low dynamic range with opacity. It may not have opacity, but it will remove the black color if you have the merge node set to over. But always keep that in mind, that the grade node comes with multiply and premultiply and grade in the middle. And then you can color grade only the foreground. Without having these two, you cannot. It will affect the foreground and the background. Having that premult is actually quite useful as well, because again, as I said before, it does help with the edges of your image. So if I go and just toggle on and off, not sure if it's noticeable, but you can see that premult is getting rid of that nasty line around the foreground layer for me. See that halo, that black line? That Premult is successfully removing this for me. So it's like killing a few birds with one stone, and it's a very, very useful node. But again, if you don't want to unpremultiply it as a separate node, that is totally fine. You can just Control Shift X to bring it out. The grade node itself can do it for you. So the grade node itself has like an embedded unpremultiply mechanism, and that's here. Unpremultiply by RGBA, and then you can just premultiply it using a separate premult node, and then go to merge node, and then you can color grade the foreground separate to the background. I hope it makes sense, but always keep that in mind, that if you're going to disable the grade node, because that's an old habit of mine, I tend to create a separate premult node. This bracket is the one that you need to be mindful of every time you want to color correct a node with opacity, potentially sRGB color space read node. Now this is something that I did exactly in here just to showcase this to you. If I bring this final result, so I had the simple read node, and those artifacts will go away as soon as you merge it to the background. I unpremulted and then added my stack of grade nodes, and they all right in the middle of unpremultiply and premultiply. So I select all these 5. So you can see I cannot color grade any of these guys without having unpremultiplied and premultiply. So that bracket, I still be mindful of that. And then you can use your grade nodes. So I add a little bit of grade using the roto, going into the mask channel of my grade node. So that roto is going to only hold the butterfly. So looking after the butterfly, and then adding a little bit of shadows to the ground, like so you can see before and after. And then I added a little bit of kind of glow to the eyes. So if I bring this one here, you can see before and after. And again, using the roto node, I'm not affecting the entire scene, I'm just targeting just the region. We talk about roto node very soon actually, so stay tuned and watch the remaining of the videos to understand how roto works. Now grade node for the power button, so you can see it turns it on, haha. And then we have another grade node, overall grade node, to darken the whole environment, added a little bit of glow here and there, and merged it with the background. I reformatted the background. We know how to reformat and why we reformat. Added a grade node using a simple ramp. And ramp is nothing more than just a rectangle, basically. It's very similar to rectangle. You specify the gradient range using ramp. And I fed that to the mask channel of the grade node. And last but not least, using a simple merge node, A over B, to get that result. Again, it's still work in progress, but the only reason I'm showing you this is to show you that I'm actually using this in my day-to-day work and in my own scenarios, having that bracket between the grade nodes and wrap it around with the multiply and pre-multiply nodes, so you can easily target the foreground without including the background. Now last but not least, how to export this out. You export out your final result using a simple write node. We have write geo, which we will explore in the future, but for now write node exports the 2D product that you have outside Nuke and bake it into an image. You can access it through here, write, or you can simply select your merge node and press W to create your write node. The only thing tricky about write node you need to be mindful of is when you double click to go to the property bin. When you go to file to specify the output, you always need to include the extension when you specify the write node. For example, I can call this test and followed by paddings, but eventually you need to go JPEG. If you wish to store it as JPEG, you need to include that, because right now, if you look at the file type, there's nothing in there. Nuke doesn't know what to pick for you. So that is an indication. So if I go save, now Nuke understands, oh, you're looking for JPEG. Here's the quality settings for you. You do the same thing when you want to export videos. Although it's very uncommon to export videos straight out of Nuke, but again, you can do that. So you have access to the Apple ProRes, H.264, so on and so forth. If you would like to see the thumbnail underneath that node, you just go to postage stamp and you can actually see that end result as a thumbnail, just display purposes in here. It is actually it is something that each node have, so you can go to even the glow node and add postage stamp enabled to have a thumbnail, but I usually keep everything collapsed, only have postage stamp for a write node to save some space. So that's a quick look at the footage, linear light space, Nuke workspace, bit depth, difference between high dynamic, low dynamic, how to color grade using Premult and Unpremult, and how to write out your file into an image. I hope you found this useful. Next, we're going to talk about rotoscopy, and we pick up where we left off in this video. So see you guys soon.